So let's draw a normal, please. Okay, so we've drawn a normal. Then we are going to draw our lens. And this time it is a concave lens. So it looks like this instead. Okay, I'm going to keep the same focal point. And I'm just going to emphasize the focal point on the other side this time. And we're going to see what happens. So, if I draw an object, and I'm going to start with an object, this first one is going to be an object that's closer than the focal point. Okay, so let's just remind ourselves what a concave lens does in comparison to a convex lens. So if I just I'll draw a quick sketch of a convex lens that we did yesterday, and we knew that the light rays go towards the focal point, or get bent towards the focal point. And that's your convex lens. But now this time in a concave lens, it does the opposite and it makes them go away. Okay, so let's just consider what that might look like. They're going to spread out. So, rather than using the focal point on the opposite side of the object, we're actually going to use the focal point on the other side, on the same side as the object. Okay, so what was the first thing we did? First thing we did was parallel line. This is a concave lens. Okay, so I will write I'll write step by step. I'm going to do it up here. So first thing we did was draw light ray parallel to the normal. Okay, now instead of bending towards the focal point on the other side of the lens, we're going to bend it from the focal point on the same side as the object. Okay, so I'm going to draw a dotted line on this side, because I draw dotted lines to represent rays that don't actually exist. Okay, and then a solid line here. Okay, so instead of drawing bending towards that focal point, yeah, we're bending it from that focal point. Okay, so the point at which our parallel line hits the lens, we're going to draw from the focal point on the same side as the object through that point. And I've just kept that part of the line dotted because it's not actually a real line. Do you remember our virtual and our real lines last time? So step number 2 is to bend this ray at the lens from the focal point on the same side as the object. Okay, now it's kind of a giveaway as to which way you need to bend the ray as from this shape that you get at the top of the lens. So obviously if it was like that, then you're going to bend it in that direction, whereas this one is like this, so we're bending in that direction. So it kind of gives away by the shape of the lens. Okay, the third point is to do exactly the same thing as what we did before. Can you remember where that line needs to go through? Through the middle where the normal meets. The lens. So number 3. Draw another second light ray from the object through, I'm going to call it the normal point. Because it goes through where the normal and the lens meet. Okay, and then point 4 will be to draw the image. So the top of our image is at the point at which the lines cross. So draw the image at the point where rays cross. It is smaller. Okay, so we're going to describe this image. So this image is smaller. What was the scientific word for smaller? Diminished. Okay, what else? Is it upright or inverted? Upright. Is it? It's closer, thank you. Closer to the lens than the object was. Also, is it real or is it virtual?
Because the dotted lines are virtual.
Okay, so dotted lines are virtual. It has at least one dotted line. So is that virtual or real? It's virtual. And a reminder of what I mean by virtual is it's not produced by the actual light ray, okay? So where this is dotted line, this dotted line is virtual, as in that's where it would go, because we've just extended our line, but actually the solid lines are the direction of the rays. Okay, let's write a title for this then. So this is an object closer than focal point Yes. To a concave lens.